In this video, we will discuss concept of limits. So let's start our topic. Limits is the initial topics which are being taught in calculus, and calculus which is generally taught in intermediate. Uh, many students find this calculus itself very scary because they don't have the conceptual clarity on this subject. So today we are going to discuss the concept of limit in detail. Now, what is limit? As per the definition, limit is a fundamental concept in the field of calculus where we analyze the behavior of a function in the neighborhood of a particular point. Limit is always determined for a function. So we'll try to find out as to what is limit, when do we find limit, and how do we find limit, and when it is required to find a limit. Now, first of all, you must have read functions in your class 9th or 10th. So let us have a small recap of that. Just quoting a few examples of function, like fx is equal to 2x plus 8. We also write it like that, y is equal to 2x plus 8. They are the same thing. Fx is equal to sin x, fx is equal to x square plus 1. These are some examples of function. Functions can be infinite in number. There can be any number of functions are possible. Now, generally in the classes till 10th, we used to find value of a function. For example, take this function. Fx is equal to x square plus 1. So if we put x as 1, this comes out to be 1 square plus 1, which is 2. Suppose you put the value of x as 3. So it comes out to be 3 square plus 1, which is equal to 9 plus 1, which equals to 10. So we can put different values of x and we'll get the value of fx. That's how we find value of function. So in all the three cases, we can put different values of x and we'll get the values of fx. But every time it is not possible to get the value of the function like this, y. Sometimes we get indeterminate forms on putting a particular value of x. What are indeterminate forms? 0 upon 0, infinity upon infinity, infinity minus infinity, 0 into infinity, 0 raised to the power 0, 1 raised to the power infinity, 0 raised to the power infinity. In this case, if we get this kind of forms, indeterminate forms, which are 7 in number and are depicted here, if the function assumes this form, any of these forms, then it is not possible for us to find the value of the function. Then we have to find the limit of the function. Now, how do we find limit of the function? We analyze the behavior of the function in the neighborhood of a particular point. Suppose you get any of these forms at a particular value, say x is equal to a. Then at x is equal to a, the value of the function cannot be found because function assumes indeterminate form. So what do? We analyze the behavior of this function in the neighborhood of a particular point where we are getting the indeterminate form. Now, let me explain it with some interesting example so that it is easy for you all to remember. Say these are certain houses in a colony, and you can see 5 houses which are adjacent to each other. There can be much more than this number. Suppose we want to have a feedback about a person living in some house, say this house. This is the house where we want to have a feedback about a particular person. So what do? We generally go to that house, meet that person, talk to him, and then we give the feedback wherever we have to give it. Now suppose the house is locked and nobody knows where this person is, and they don't know that when he is going to come back. Then what will you do? And you have to give the feedback today. It's very urgent to give the feedback. What will you do? You will just go and talk in the neighborhood. Say, take from the right, go to this house, try to find about this person, then come a bit closer. This house is next door neighbor. Or you can start from the left, start from this house, move toward this house. This is also his next door neighbor. The next door neighbor or the houses which are in the proximity will have a better feedback about this person. Here we have only depicted 2 houses on the right and 2 on the left. We can have many more. So if we start from right or we start from left, we will try to have a feedback about this person. Now, if on the right the feedback about this person is positive, on the left the feedback is again positive, so we'll say the feedback is positive. Now, if the feedback on the left is, say, some negative, here also we have negative on the other side. So this is the feedback which we are getting from the both sides. We'll take this as a feedback. However, if we get a positive feedback from left side and negative from right, negative from left or positive from right in 2 cases, in both the cases feedback is confusing. Feedback does not exist. Which to take? Which feedback will you take? That means feedback does not exist. Now come back to mathematics. What I said, if the function assumes indeterminate form, then we cannot find the value. That means house is locked. Then what do? Around that particular value of x, go in the neighborhood, go in the right neighborhood and try to find the behavior. On the left neighborhood, again try to find the behavior, means value. If both these values matches, that is the limit. If they do not match, limit also does not exist. So this is just an example to explain you. Let's go again into mathematics and try to understand how we find the limit of a function. Now, consider this function fx or y is equal to x square minus 1 upon x minus 1. At x is equal to 1, if you put the value of x as 1 square minus 1 upon 1 minus 1 is equal to 0 upon 0. So this function assumes indeterminate form, right? That means you cannot find the value at x is equal to 1. Now we are only having an option to find the limit. So what do? Like in the example I discussed few minutes back, we'll go towards right and then proceed towards that number, or we go towards left neighborhood of 1 and then proceed towards 1 and see what value does the function approach as it extends towards 1. Now let's make it a bit easier and draw a table. Right. So this is a table. We'll plot different values of x and correspondingly we'll plot the values of fx. For x is equal to 1, fx is undefined, indeterminate. Okay, go towards right. Take the value of x as 1 plus 0.1. Now if you put the value of x as 1.1, fx f1.1 equals to 1.1 whole square minus 1 upon 1.1 minus 1, which equals to 1.1 minus 1, 1.1 plus 1 upon 1.1 minus 1. This gets cancelled out. So fx becomes 1.1 plus 1, which is equal to 2.1. We have written 2.1. Move a bit closer, say 1.01. So you can easily see that the value will come as 2.01. Move a bit more close to 1.001. The value will come as 2.001. These are only 3 values of x we have taken. We can take many number of values. Now, from left, go towards left from 1, say 0.9. If you take the value of x as 0.9, f 0.9 is equal to 0.9 whole square minus 1 upon 0.9 minus 1, which is equal to 0.9 minus 1 into 0.9 plus 1. You can take a square minus b square form, 0.9 minus 1. Again, this will get cancelled and f0.9 will be 1.9. So the value will be 1.9. Move a bit closer. Take value of x as 0.99. The value of fx will be 1.99. Move a bit more closer, 0.999. The value of fx will be 1.999. Now it can be easily seen as you move from right towards 1. That means as x tends towards 1, the value of fx tends towards 2. You can see 2.1, 2.01, 2.001. So the value is becoming closer and closer and closer to 2. Or you move from left. Say you move from left towards 1. There also you can see 1.9, 1.99, 1.999. That means fx is moving closer to 2. That means from both sides, whether it is from right or it is from left, the function is moving closer to 2. That means the limit of the function is 2. And we write like that. Limit, we write that LT x tending to 1 fx is equal to 2. So hence we write limit x tending to 1 fx is equal to 2. And we read, just see how we read it. Limit x tending to 1 fx is equal to 2. Tending to 1 means x is tending towards 1, whether from the right or from the left, but it is not 1. It is only tending towards 1, right? It's getting very, 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 very extremely close towards 1, but it is not 1, because at 1 function is undefined. When x becomes 1, function is undefined, indeterminate form. Now just see the difference. When you find value at a particular uh, point, say x is equal to a, we write this is the value at x is equal to a. But when we find limit, we write x tending to a and not x is equal to a. We don't write like this. We write x tending to a, which means x is tending towards a. So this is one way of finding the limit. Let me also explain graphically. Now, before we try to understand graphically, let's revisit a very small concept from coordinate geometry. We must have been knowing that any line which cuts an intercept of A and B on x-axis and y-axis respectively, A and this is B, this line passes from A0 and 0B. The equation of this line is x upon A plus y upon B is equal to 1. Now, depending upon the value of A and B, whether they are positive, negative, one positive and one negative, we will have the orientation of line. Now, let's draw the graph for this function. Fx is equal to x square minus 1 upon x minus 1. See, we have written now that x is not equal to 1. This function is only valid when x is not equal to 1. When x is equal to 1, this assumes indeterminate form. Now, you can write like that: fx is equal to x square minus 1 upon x minus 1, which is equal to, you can write 1 as 1 square, x minus 1, x plus 1 upon x minus 1. This will get cancelled out. That means fx is equal to x plus 1. So if you cancel out this x minus 1 from numerator and denominator, the function assumes this form. But say this is 1 and this is 2. 1 or 2 are not the same function. In 1, you have x minus 1 in numerator and denominator. So this has a problem when you put x is equal to 1. But in 2, you don't have that in denominator and numerator. So this function doesn't have a problem at x is equal to 1. So they are different function. So now the function fx becomes y is equal to x plus 1. This is only valid when x is not equal to 1. Right? That means minus x plus y is equal to 1. X upon minus 1 plus y upon 1 is equal to 1. So now compare with the form x upon a plus y upon b is equal to 1 and trace the line. So we draw the graph here. X on this side and fx y on y-axis. So this line will have an intercept of minus 1 on x-axis, means it will pass from 1, and 1 on y-axis. So the line will be roughly look like this, right? But at x is equal to 1, there will be a gap, because at x is equal to 1, function is not defined. So let's draw it properly. The line y is equal to x plus 1 can be traced like this. It will have a small gap shown in red, a very small, extremely small, and the line will be continuous after that, right? So this is the graph of the function. At x is equal to 1, you can see the function is not defined. That is why we have made a small gap which is red in color. Now what do? We go towards right, say take some value which is more than 1, take a value more than 1, say like this, and for this value you try to find the value of fx, which will be this, like this. So if you take a value more than x, more than 1, the value of fx becomes this. Now come a bit closer to 1, take a value which is close to 1, then you will get again a value of fx. Again come more close, you will get the value of fx as this. So as you start moving from right side towards 1, what we are doing here, we see the value of fx is tending towards 2. Similarly, if you move towards left and you take this value left of 1, you will get value of fx like this. Move again from the left towards 1, you will get this value. As you start moving towards 1 from the left side, you see the value again start approaching 2. So we can easily see from the graph that as we approach 1 from right, the value of fx approaches 2. Similarly, from left also it approaches 2. So the limit in this case is 2. We have seen from tabular form, and we have also seen from graphical form. But everywhere it's not possible for us to draw a graph or table. We have other methods. In fact, we have many methods of evaluating the limits. I will discuss 2 only here. There are many other methods which are available in books. You can go and refer your books. And also when I'll be posting the whole course of calculus, I'll be discussing all the methods. But here I'll only discuss 2 methods. But what do we do when we evaluate limit of any function? Means we apply any method, but what is the thing which we do? We try to bring out the function from this indeterminate form. We see that function comes out of this indeterminate form. So there are certain algebraic methods by which we try to do this, and we try to get the limit. Now, for example, first is factorization. In some particular forms, factorization is possible. Then we use factorization and bring the function out of this indeterminate form. For example, evaluate the limit of this function. Now you can easily see that x square minus 25 upon x square plus 2x minus 15, limit x tending to minus 5, right? This is equal to, now suppose you put the value of x as minus 5. So this function assumes the form minus 5 whole square minus 25 upon minus 5 whole square plus 2 into minus 5 minus 15, which is equal to 0 upon 0. So this is indeterminate form. So you cannot find the value at x is equal to minus 5. That means we have to find limit at x is equal to minus 5. So what do? We'll just check out whether it is possible to factorize this expression in the numerator and denominator and try to cancel out something so that it comes out of this indeterminate form. Let's see. Now x square minus 25 can be written as x square minus 5 whole square upon x square plus 2x minus 15 can be written as x plus 5 into x minus 3. Limit x tending to minus 5, which equals to limit x tending to minus 5, x minus 5, x plus 5 upon x plus 5 and x minus 3. Now just wait here and see. When you put the value of x as minus 5, this becomes 0 and this becomes 0. So these were the factors which were responsible to make indeterminate form at x is equal to minus 5. Here they cancel out. So now you are left with x minus 5 and x minus 3. Now you can put the value of x as minus 5. So this will translate to minus 5 upon minus 5 minus 3, which is equal to minus 10 upon minus 8, which equals to 5 by 4. So this is the answer to this problem. I hope you have understood this method of factorization. Let's see one more method. The other method is rationalization, because everywhere it is not possible to get the factors. So what do? We rationalize either the numerator or the denominator. What do? We multiply by conjugate. What is conjugate? Say if we have expression as a plus b, the conjugate of this is a minus b. If you multiply both, you will get a square minus b square. And if you have a minus b, the conjugate of this is a plus b. So if you multiply both of them, again you get a square minus b square. So here we take advantage of this form, a square minus b square. Just see how we do it. Now suppose you have to evaluate the limit. Limit x tending to minus 3 under root 2x plus 22 minus 4 upon x plus 3. Now this function assumes indeterminate form at x is equal to minus 3. How? If you put x as minus 3, this will be minus 6 plus 22 minus 4 upon minus 3 plus 3. So the form becomes 0 upon 0, indeterminate form. So you can't get the value at x is equal to minus 3. That means you have to find the limit of the function at x is equal to minus 3. Now just see how we do it. Limit x tending to minus 3 under root 2x plus 22 minus 4 upon x plus 3. Now here it's not possible to factorize. Denominator, you don't you can't factorize because it is already x plus 3. Numerator, there is an under root there, so you can't do it either there. So what do we do here? We will multiply by the conjugate, under root 2x plus 22 plus 4. This is the conjugate. Now you have no right to multiply like that. So if you have multiplied in the numerator, same way you do in the denominator, so that they both cancel out. 2x plus 22 plus 4. Now it doesn't make any difference. Now what will happen in this two expression numerator? They will become under root 2x plus 22 whole square minus 4 square. That means 2x plus 22 minus 4 square is 16. We are using the formula a square minus b square, and in the denominator you will get x plus 3 under root 2x plus 22 plus 4, right? Here it will become plus 22 and minus 16. So it will become 6, and you take 2 common, then it will become x plus 3, right? Now you can see, as you put the value of x as minus 3, this becomes 0, and in the numerator this also becomes 0. So these were the factors which were responsible to bring the function in indeterminate form at x is equal to minus 3. They cancel out here. So now you can easily put the value of x as minus 3. So the function becomes 2 upon under root minus 6 plus 22 plus 4, which is equal to 2 upon 4 plus 4 means 8, which is equal to 1 upon 4. And that's the answer. So this is the second example of evaluating limit of a function. There are some other methods also by which we can find the limit, but we restrict ourselves to 2 methods only, and I hope that both these methods are clear to you, and that's all which is there in the limits. That's all in this video on concept of limits. I hope you enjoyed this, you found it interesting. So thanks for watching and have a nice day.